Good day, students. Today we are going to study how to find out PDNF and PCNF for any given formula. For that purpose, now we shall learn a few connectives called complement, disjunction, conjunction. There are many connectives, but today we learn only three connectives. To define complement, one variable is needed. Variable is otherwise called a statement, proposition, etc. Complement is denoted by dash. In set theory, to define a complement, we need only one set A. Likewise, here also we need only one variable. Call that variable as P. P is a statement, any sentence. That sentence may be true or false. For example, the sun rises in the east. This sentence is a true statement. Another one, the sun rises in the west. If the sentence is the sun rises in the west, it is a false statement. Okay, so for any given statement, there are two possibilities. Either it is true or false. TF. We denote, if the statement is true, we denote it by T. If it is false, it is denoted by F. Okay, T and F are called as truth values of P. So if P is T, if P is true, then P complement is F. If P is F, P complement is T. Okay. If X is a member of A, then X is not a member of A dash. If X is not a member of A complement, then X is a member of A. You can relate this with set theory. The next connective is disjunction. We can relate two variables by a connective called disjunction. To define disjunction, two variables are needed. This is like union in set theory. To define union, we need two sets A and B. Here we need two statements P, Q, P and Q. So what are the various truth values for P and Q? Both are true. P is true, Q is false. Third case is P is false, Q is true. The last case is both are false. Case 1, if P is T and Q is T, what is the answer for P cup Q? In set theory, if X is a member of A as well as member of B, then X is a member of A union B. Likewise, here P is true, Q is true means P cup Q is also true. Case 2. If P is T, Q is false, you can relate this with set theory and find out the answer for P cup Q. That means if X is a member of the first set A and X is not a member of the second set B, still X is a member of A union B. So for the truth values TF for PQ respectively, the truth value of P cup Q is T. Third case, P is false, Q is T. Still, P cup Q is T because X is not a member of A and X is a member of B means X is a member of A union B. So X is a member of A union B if and only if X is a member of A or B or both. If X is neither a member of A nor a member of B, then X is not a member of A. Only in the last case that P is false and Q is false, P cup Q is false in all the other cases. First three cases, P cup Q is T. Okay, definition of P cup Q is over. Cup is called as disjunction. Okay, disjunction is denoted by cup. Next, we shall see conjunction. As in the case of disjunction, we can relate two variables by a connective called conjunction. It is denoted by cap. This is same as intersection in set theory. If X is a member of A and X is a member of B, then X is a member of A intersection B. In all the remaining three cases, what are those remaining three cases? X is a member of A, not a member of B. Next case, X is not a member of A, but a member of B. Then another case, X is neither a member of A nor a member of B. In all these three cases, X is not a member of A. Likewise, here also, in the last three cases, P cap Q takes the truth value F. In the first case alone, it takes the truth value T. We shall see min terms and max terms if two variables P and Q are involved in a formula. Which is minimum? A union B or A intersection B? Intersection contains minimum lesser number of elements, and union contains more number of elements. Okay, so the min terms are, the various min terms are, if when two variables are involved, P cap Q, P cap Q dash, P dash cap Q, P dash cap Q dash. These are the four min terms when two variables P and Q are involved. The first place is occupied by P or P dash. Second place is occupied by Q or Q dash. So first place is occupied in two ways, second place is occupied in two ways. So totally there are four min terms. Similarly, if cap is replaced by cup, we get max terms. P cup Q, P cup Q dash, P dash cup Q, P dash cup Q dash. What are the min terms and max terms if three variables P, Q, or are involved in a formula? Okay, first place is, there are three variables. First place is occupied by P or P dash. Second place is occupied by Q or Q dash. Third place is occupied by R or R dash. Okay, so 2 into 2 into 2, 6 possibility, 8 possibilities. 2 into 2 into 2, 2 cube, that is 8 possibilities are there. Okay, so 8 possible min terms and 8 possible max terms. P cap Q cap R, P cap Q cap R dash, P cap Q dash cap R, P cap Q dash cap R dash, P dash cap Q cap R, P dash cap Q cap R dash, P dash cap Q dash cap R. The last one is P dash cap Q dash cap R dash. If all these conjunctions are replaced by cup, you will get the corresponding max terms. What is principal disjunctive normal form? Disjunction. Disjunction means sum. It is sum of products. Principal conjunctive normal form. It is product of sums. Sum of products is sum of min terms. Product of sums is product of max terms. Problem. Put the function k equal to, one formula has been given for k, in PDNF form. We shall write PDNF and I'll teach you how to write down PCNF form also for this one. Name the formula as K. Okay, there are two sections. In order to simplify the length of the headings, I name the first part as G and the second part as H. G is X cap Y dash the whole dash cup Z dash. H is X dash cup Z the whole dash. We shall write down the answers for G and H and then G cap H. Finally, we shall write the answer for K. You know the definitions for cap, cup, complement, which we have seen above. Okay. What are the various first three columns? What we write the various truth values for X, Y, Z. Against the columns Y, Z, write T T T F F T F F. Repeat it again. T T T F F T F F. Below the headings Y and Z. Okay, first four places are replaced by T for X. The next four places are replaced by F. Okay, in book this order is followed. Okay, we shall also follow the same order. Below Y Z, write T T T F F T F F. Again repeat the same set T T T F F T F F. For the first four cases, first four rows, replace X values by truth values T. For the next four cases, replace the truth values for X by F. Okay, this is the order we follow. Now you know how to write down X dash, Y dash, Z dash, and then X cap Y dash, and then X cap Y dash the whole dash, and then G, and then X dash cup Z, X dash cup Z the whole dash, okay, which is equal to H, and then G cap H. G cap H is K. G cap H is K. Okay, after filling the entire table, why 8 rows are present here? Since 3 variables are involved, X, Y, Z, 2 into 2 into 2, 2 cube possibilities. Okay, therefore we have 8 rows. If 4 variables are involved in a formula, you will have first one is replaced by X or X dash, second place is replaced by Y or Y dash, third place is replaced by Z or Z dash. Suppose the fourth variable name is T, the fourth place should be replaced by T or T dash. In that case, 2 into 2 into 2 into 2, 16 rows you will have. Okay, after finding out this entire table, in K column, that is formula column, check where T values are present. Okay, here in this example, second row of K gets T and fourth value of K gets T. Okay, now we shall start writing PDNF. PDNF is sum of products. Product is minterm, sum of minterms. In second row, K value is T. So in second row, check the truth values of X, Y, Z. What are the truth values of X, Y, Z? T, T, F. Okay, so using this T, T, F, frame the corresponding minterm. It is X cap, Y cap, Z dash. Okay, in fourth row, K gets the value, truth value T. What are the corresponding truth values of X, Y, Z in fourth row? T, F, F. The corresponding minterm is x cap, y dash, cap, z dash. Okay, therefore, using these two minterms, find the sum of minterms. So, in between these two minterms, put cup. We get sum of minterms. So, final answer for K is, in terms of PDNF, we have written down the answer. Okay, there are only two midterms since there are only two t values for K. If nowhere it is t, if it is a contradiction, all the last truth values in the last column takes the value f. There is no PDNF. There is no PDNF for a contradiction. Okay, what is a contradiction? All the entries in the last column gets f. That means for no possible values of x, y, z, k gets the value t. Everywhere it is f. If everywhere it is a f, it is called as contradiction. If everywhere it is t, it is called as a tautology. Next, how to frame PCNF for k. In second row and fourth row, we have got T. In all the remaining 6 rows, we have got F as truth values of K. Now, using these remaining 6 rows, we are going to frame PCNF. PCNF is product of sums. Sum is a max term, product of max terms. Okay. Now, what max terms we have to write down? Take the first row. In first row, K gets the truth value F. What are the corresponding values of x, y, z? T, T, T. X is T, Y is T, Z is T. Okay, in previous case, while framing PDNF, we had taken the truth values of x, y, z as such. Now here we are not going to take the truth values by x, y, z as such, that we are going to negate it and consider. T, T, T goes as negated. After negating, we get F, F, F. So using F, F, F for the first row, what is the corresponding max term? X dash, cup, Y dash, cup, Z dash. Okay. Then pass on to third row. In third row, K gets the value F. The corresponding values of X, Y, Z are T, F, T. After negating T, F, T, we will get F, T, F. What is the corresponding max term for F, T, F? X dash, cup, Y cup, Z dash. Likewise, frame max terms for all the 6 rows. Okay, and then take the product. Product is intersection. Okay, cap of all these max terms. Suppose nowhere it is F, everywhere it is T. Okay, all the truth values of K is T means it is a tautology. Okay, for all possible combinations of X, Y, Z, K becomes true. That means K is a tautology. If it is a tautology, there is no PCNF. There is no PCNF for a tautology. There is no PDNF for a contradiction. Okay, today we end this class. Thank you.